casting. Casting is what you use. It's not what you put on your leg when you hurt yourself. I mean, that's a joke that we make whenever we're talking about casting. But casting is where you temporarily convert a value. So in this case, we've got pi, 3.14159. We cast it to an int. That makes it temporarily just give us the 3. It basically just lops off all the decimals, and we don't have to deal with that for the time being. Then when we have double 3, we temporarily cast 3 to a double, so it technically is that point is 3.0. Your casting is not permanent. It only changes those values temporarily. Here we have some examples. We've got 1 is 1, big is 453, and then decimal 7.56. We can mix those around. When we mix them around and you try to put the decimal into an integer, that's a loss of precision, which is what we saw before when we were dealing with this initially. And then you put big into 1, big is a long, can't put a long into an integer. That's basically a loss of precision too. And then we have decimal and we have big, and we're casting both of those to integers. When we put that in cast on there, that's a temporary conversion. It allows that assignment to work because the data types match up. So once again, casting is a temporary change. In this example, we've got 11 and 5. If you did standard integer division on 11 and 5, 5 goes into 11 2 times, you're left with a remainder of 1. But if you temporarily change 1 to a double with the cast, now you're going to get a fractional value when you do 11 divided by 5. So that's handy, right? The ability to change a value but not temporarily change it is very useful for whenever you're writing code. And here we just got a whole lot more examples of casting 1 in a 1 divided by 2 whole number situation will temporarily convert one of those values into a double so that you get decimal results. These are some things that you just need to go into and mess around. So let's go look at some code to make sure we totally understand how this works. Casting, hang on, I think I want to do this other one. Which one do I want to do first? Oh yeah, let's do this. Let's do this one first. It's a little on the simpler side. So let's run this real quick. There we go. So 1 divided by 2 integer division we looked at a while ago was 0. 1 is an integer, 2 is an integer, you get 0, 2 goes into 1, 0 times, you're left with the remainder of 1. On the next line, we temporarily cast the 1 and the 1 divided by 2 to a double. That enables us to get a fractional value because now we have double divided by integer. On the next line, we have 5 divided by 2. 5 divided by 2 with integer division is 2. On the last line, we do a cast to temporarily convert the 2 into a decimal, which would be 2.0, which enables us to get a 2.5 value. So these are some things you just got to play around with them. You got to change them up, come in here and use some different values to make sure that you understand the difference between integer division and real number double division. Okay, so here we go. We have an int cast being placed on 3.14159, which is basically just pi, but only a few digits of pi. That gets us 3. Lops off the 0.14159. So it takes like a big axe and chops off those decimal places, and then all you're left with is the whole number part. On the next line, we take 3, which is an integer, we cast it to a double, we get 3.0. And then as you go along, I'm doing some conversions, right? I'm doing some assignment so we can see what happens if I try to put this value into this value. So on the first line here, on line 13, I have 1 equals decimal with an int cast on it. If I take that int cast off, I'm now attempting to put a double into an integer, which is not allowable. So I'm going to run this and I'm going to get basically a loss of precision because it's going to tell me, hey, you can't do that. So now I'm going to go back, I'm going to put my cast back in. Oh, that's not a proper cast. I actually typed the word cast. That's not going to work. Put that back. Now I'm in good shape. So basically the int cast on this one basically says, give me just the integer component. Treat this like an integer. That way I can assign it over. So it basically takes off all the decimals, lops them off, and all I'm left with is the whole number. And I'm doing the same thing here too. The one that you really need to be aware of is the int cast, where we're casting the decimal, chopping off the decimal places to put it in an int. The other one that I'm looking at here is I have a long. It's too big to fit in an integer, so let's take off that int cast. I'm going to get another loss of precision because it's too big, it won't fit. So now I have to come in and I cast the long to an integer, which trims it down where it's that conversion, that copy over process is allowable. Same thing on the last one, right? The last one, I'm converting the decimal value into a value that can be stored into long. And I believe, if I remember right, I haven't done this in a while, I can perform a little trickery here, and that'll work as well. So an int can be stored in a long, an int can be stored in a decimal, but a decimal and a long cannot be stored in an int. So this right here, we're ramping it up. This is getting pretty sophisticated. So you need to go back through these examples on your own, go back and look at them, change the values, make sure that you understand exactly how this works, and that you can take what was in the slide examples and match it up to what's in the code. Now that we've had some fun and we've really cranked up our ability to make some things happen. We know how to use math operators now. We can put them into expressions. We can put casts on things, keep us from breaking things, if you want to think about it that way, right? The cast prevents something from breaking. That's kind of handy. Cast in the real life doesn't work that way. You put it on after you break something, but in code it's a little bit different. So now that you got all this down, now you can go into some code, into some programs, and actually see if you can make this work and solve some problems. So now it is time to go and crank some code.